If you understood this, then tell me next situation, if the same block is allowed to go down with an acceleration A and if the block goes distance D downward, tell me what is the work done by tension now. Now block is going downward. First thing, sir, if the block is going downward, again same formula. So work of tension you want, again I will write, sir, Fs cos theta. Now you know system is going downward now, so tension G effective will become G minus A. So tension in the string will become M into G minus A. Distance is D. Can you tell me what will be theta now? There theta was 0, what will be theta now? Theta will be 180 now because tension in the string will again act upward away from the block. Displacement is down. So you can see both will have angle 180 degree. Now theta will be 180. So here you will put cos 180. Cos 180 will give you minus 1. So work done final will be coming as minus of M into G minus A into D. This is the work of tension. Is it okay? Is it okay? समझ में आया? Most of the people said M into G minus A into D. That was wrong answer. Here tension will do negative work because tension will act on the block upward. Displacement of the block is downward. So you cannot say theta will be 180, not 0. Previous situation, block was also going upward, tension was also upward. That's why work done was positive. Here tension will be upward, block is going downward, work done will be negative. Done. Bolo. And always remember, sometimes this D you have to calculate by yourself because they will say particle is starting from rest. They will say system is starting from rest. So distance D you can find in time T. Using equation of motion, D will be equal to half AT square. Many times D is also not given. If D is not given, then you have to calculate D with the help of equation of motion. Acceleration known na baba, time they will give you, find the work done in time of 2 seconds, then you can use it. Using second equation of motion, you can find D. Is it okay? You can write one question. Come on, Torga. You write. You write one question. You write. A block is lower down. You write. A block is lower down. Yeah, see the language how question is asked. You write. A block is lower down with A equal to G by 3. A block is lower down with A equal to G by 3. If it moves down by distance D, a block is lower down with A equal to G by 3. If it moves down by distance D, find the work of tension. Find the work of tension on the block. Find the work of tension on the block. No need to use this formula. You will not be able to remember this formula. So go with the concept which I told you. Remant, very good. Don't use formula. I did not say you any formula. I just told you method to calculate. Don't put in the formulas to get the answer. Use your entire method. Amrut correct. Vijay Salim correct. Kusma correct. Visheshya correct. Gyaneshwari, no problem. You can see the question. People are saying answer positive. Ramya, your answer is wrong. Block is going down. Work done by tension will be negative. Both will be in option. Positive value will be also option. Negative value will be also in option. So don't do mistake. Simply, no need of any formula. बहुत आसानी से. You will do very easily. You will simply say draw the diagram. You will always get the answer. I will simply say, sir, block is going down. Block is going down with A equal to G by 3. So first I will calculate tension in the string, sir. We have already studied in G effective, sir. There, when the system goes down, G effective will become G minus A. So tension in the string will become, sir, M into G minus A. A is our G by 3. So tension in the string will become, sir, 2 mg by 3. Now, sir, tension is upward, block is going down. How much distance block went down, sir? Block went down by distance D. So work done by tension, I know, sir, Fs cos theta. Now from here, F will be coming as whose work you are calculating? You are calculating work of tension. So you have to see the tension force. So 2 mg by 3 into distance d. Distance is d into cos theta. बताओ theta. Cos theta बोलो. How much theta will come? 0 degree or 180 degree? जल्दी बता दो भाई. Theta will come how much? Theta will come how much? जल्दी. त्वरगा. Time ले दो. How much theta will come? 180. Theta will come 180. So from here at 180, everyone knows this will give us -1. So final answer will become -2 mg d by 3. This is the answer. Yeah, so no need to, these are not formula. Don't think you will sit and remember them. It's not possible to remember every formula na baba. Here formula, without formula you can do. Find the value of tension, then see whether block is going up or down, then use the formula Fs cos theta, you'll get the answer. Done, done, done. Bolo, 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 ho jayega, ho jayega, ho jayega. Everyone will be able to do question based on work done by tension. Bol do bhai. एक बार बता दो, then we'll move further. Okay, फरीदा, जल्दी बताओ. हाँ, बहुत बढ़िया, बहुत बढ़िया. Now third and last special situation we will talk. You write work done by kinetic friction. हाँ, perfect sir, बहुत बढ़िया. Yeah. Third situation we will talk, which is our last special situation. You can write work done by kinetic friction. Work done by kinetic friction. And you can always find work of kinetic friction because it's an easy situation. Nothing to worry. Nothing to worry. No problem. No problem. Yeah. Why we are taking kinetic friction? Because we will take block moving on the surface. If block is moving on the surface, kinetic friction will act. People ask, sir, why you are not talking about work done by static friction? Here we are talking about motion of the block. Block will be moving on the surface. If the block will be moving on the surface, it's clear that kinetic friction is there. So even they ask you find work done by friction or will they ask you work done by kinetic friction, both will have same meaning. Friction also, if they will talk about friction acting, will be our kinetic only. So that's why we will say, sir, work done by friction, they ask. Yeah, generally it is zero visesya, not always. Yeah, yeah, okay, but generally work done of a static friction will be zero, but not mandatory, yeah, okay, no problem, yeah. So for example, someone says, sir, a block is there, this block moves, this block makes displacement S. Block came from here to here by making displacement S. You know, when the block will go from here to here by making displacement S, at this time friction will act opposite to the motion. You already know friction acting will be our kinetic friction. Friction acting will be our kinetic friction. So they will say a block displaces by distance S. Find the work done by friction or find the work done by kinetic friction. Both will have same meaning. So again I will say, sir, you want work done by friction now, you want work done by kinetic friction now. So again same formula, Fs cos theta. Now force whose work you are calculating is the kinetic friction. So Fk into S into cos theta. But what will be theta here? Theta will be 180. Yeah, Harita also very good. Yeah. Okay. Theta will be how much? Batao. You know friction will oppose the motion of the block. So friction will act backward. Block is going forward. So theta will be coming as 180. Cos 180 means you get -1. So for what you will be getting as minus. This minus will come here, minus Fk into S. And Fk you can find, kinetic friction you know, mu k into N into S. This is a work done by kinetic friction or simply you can say work done by friction also. Both will have same meaning. Is it okay? Is it okay? Why are you not writing here n equal to mg? Is it better that will be always g? Generally we write now m into n we write here mg theta. It is not horizontal surface now. So I always write m will be always equal to mg. No, you have studied in pushing thing. N will be increased. N will become mg plus f sin theta. Depending on pushing and pulling, value of n will be changed. mg. It depends if any other force is acting on the body or not. If no other force is acting, n will be equal to mg. But if some force is you're pushing the block or you're pulling the block, normal reaction will change. So that's why we are taking general value of n. And we know this n will depend on situation. Sometimes it may be mg, sometimes it's more than mg, sometimes it's less than mg, depending on what we are pushing the block or pulling the block or we are not applying any other force. Is it okay? And if you remember, I have said you one in one also question is very changing. They are dancing the law. So normal reaction will become mg plus sin theta. अरे बाबा no problem. So these are the situations that we have. I know what you did. Somebody first name you obsess. I don't reply them because I want to discuss this question in class. I'm giving you my two serious this question. We will further one concepts that we are going to introduce. Homework and for area. I'm giving you my five serious situations. Once completed your sentence, we will be more further. One very important part we are going to start. One more part we are going to start. Done, sir. I know one sentence is saying done. No problem. Yeah. So we are going to move further. We are going to talk about one more concept which is asked from here, which is important from here. Yeah. Okay. No problem. Yeah. Okay. No problem. Yeah. So now we are going to talk about types of energy which a system can have. First we will talk about it will be maybe only best is the knowledge maybe energy. You can do like that, no problem. Yeah. Now we move forward. We will talk about one type of energy, like kinetic energy. You can write kinetic energy and momentum. We'll study relation between kinetic energy and momentum. Kinetic energy and momentum. Kinetic energy and momentum. And be focused. See, yeah. Always remember, whenever any body will move now, due to its motion, it will have two things. One will be momentum, which you already know will be equal to mv, and other will be kinetic energy, whose value everyone knows. Kinetic energy will be equal to half mv square. And be focused. Yeah. Always remember, due to motion of the body always possesses some energy. For example, if the body is running now, if a person is running now, if you want to stop that person now, it will not stop naturally. You have to apply some force, you have to do some work. That means moving body has some energy. That energy which body gets due to motion is known as kinetic energy. So always remember, ध्यान दो. Be focused. Just here, yeah. Okay, no problem. Yeah. Always remember, due to motion, every body has one energy. That energy we represent as kinetic energy K. And this K will be equal to half m into v square. This is the kinetic energy. Whenever any body of mass m will move with speed v, always remember v is not velocity. V is actually magnitude of velocity, that is the speed. And people do mistake here. Never think that kinetic energy is half m into v square. V is the velocity, wrong. Always remember, v is the magnitude of velocity. V is your speed. So whenever any body of mass m moves with speed v, it will always have kinetic energy. K will be equal to half mv square. And you also know this moving body will also have some momentum. magnitude of momentum will be coming as m into v. Is it okay? Everyone knows this thing, that moving body will have always kinetic energy, sir, half mv square. Moving body will always have momentum. Magnitude of momentum is m into v. Is it okay? हाँ, बहुत बढ़िया, बहुत बढ़िया. And always remember, we can always relate kinetic energy and momentum, because numericals are asked based on kinetic energy and momentum. They will say if momentum is doubled, what will happen to kinetic energy? So we are trying to derive the relation between them. So see the relation between kinetic energy and momentum. Just see here. Okay, no problem, no problem. Yeah. Now, if you want, you can write this as, just see here how to get the relation between kinetic energy and momentum. Just see here, yeah. After that, you have to remember that result also. Most of you are knowing kinetic energy will come P square by 2m. So I'll just derive it very fast. Just see here, yeah. What we do here, in order to get relation, what I will do, half. I will multiply with m and divide with m. I will multiply with m and divide with m. When you multiply with m, it will become m square by v square and divide by m. Same result I am writing. I am multiplying with m, so m into m will become m square, and again I am dividing by m, so that no change will happen. Now from here, if you observe, this will finally become, sir, half. This will become m square v square. You can write directly as mv whole square by m. And this mv is nothing, this mv is your momentum p. So that's why we will say kinetic energy will come, sir, half of p square by m, or simply we remember it like this, that k will be equal to p square by 2m. This is the result from where question has been asked. At least 10 previous year NEET question has been asked from here. Kinetic energy of a body is related with momentum. K will be equal to P square by 2m. K will be equal to P square by 2m. K will be equal to P square by 2m. Is it okay? Is it okay? बोलो बोलो भाई त्वरगा. Then we start with numericals from here. No problem, no problem, no problem. Yeah, kinetic energy will be equal to P square by 2m. Or if kinetic energy is given, you can find momentum also. Reverse relation also you can write. From here you can also write that. You can send this side, square this side. So P will be coming as under root of 2k into m. This is also relation, no need to remember this, only this is enough. So k will be equal to p square by 2m. If they ask us about p will become under root of 2km. If they ask us about k will become p square by 2m. I will give you one question, come on. You write. Two particles of mass 1 kg and 4 kg, two particles of mass 1 kg and 4 kg, two particles of mass 1 kg and 4 kg have same momentum. Find ratio of their kinetic energy. Find ratio of their kinetic energy. Find ratio of their kinetic energy. Two particles of mass 1 kg and 4 kg have same momentum. Find ratio of their kinetic energy. Srinivas Reddy, very